Away ahead.
Scattered across our Milky Way are tens of millions of black holes, powerful gravitational wells of spacetime, from which matter and even light can never escape. Black holes are dark by definition, except on rare occasions when they feed. As a black hole pulls in gas and dust from an orbiting star, it can give off spectacular bursts of X-ray light that bounce and echo off the inspiraling gas, illuminating a black hole's extreme surroundings. Now MIT astronomers are looking for flashes and echoes from nearby black hole X-ray binaries, systems with a star orbiting and occasionally being eaten away by a black hole. The researchers used a new automated search tool, which they've coined the reverberation machine, to comb through satellite data for signs of black hole echoes. In their search, the team has discovered 8 new echoing black hole binaries in our galaxy. Previously, only 2 such systems in the Milky Way were known to emit X-ray echoes. Across all systems, they observed that a black hole first undergoes a hard state, whipping up a corona of high-energy photons and a jet of particles that is launched away at close to the speed of light. The researchers discovered that, at a certain point, the black hole gives off one final high-energy flash before transitioning to a soft, low-energy state. This final flash may be a sign that a black hole's corona, the region of high-energy plasma just outside its boundary, briefly expands, ejecting a final burst of high-energy particles before disappearing entirely. These findings could help to explain how larger, supermassive black holes at the center of a galaxy can eject particles across cosmic scales to shape a galaxy's formation. The role of black holes in galaxy evolution is an outstanding question in modern astrophysics, says Erin Kara, assistant professor of physics at MIT. Kara and her colleagues are using X-ray echoes to map a black hole's vicinity, much like how bats use sound echoes to navigate. When a bat emits a call, the sound can bounce off an obstacle and return to the bat as an echo. The time it takes for the echo to return is relative to the distance between the bat and the obstacle, giving the animal a mental map of its surroundings. Similarly, the team is looking to map the immediate vicinity of a black hole using X-ray echoes. The echoes represent time delays between 2 types of X-ray light. Light emitted directly from the corona, and light from the corona that bounces off the accretion disk of inspiraling gas and dust. The team's study, whose first author is MIT graduate student Jingyi Wang, was published in the Astrophysical Journal. The team developed a search algorithm to comb through data taken by NASA's NISA, a high-resolution X-ray telescope aboard the International Space Station. There were reverberation signatures in 8 sources, Wang says. Sound waves can, in fact, form in space when there are enough media, like the gas and dust found in a galaxy cluster, to propagate through. As a side project, Erin Kara teamed with 2 MIT education and music scholars to convert the emission from a typical X-ray echo into audible sound waves. Well then, take a listen to the sound of a black hole echo. This isn't the first time scientists developed a way to listen to distant cosmic bodies. Recently, NASA released a data sonification made from the pressure waves emitted by a black hole at the center of the Perseus galaxy cluster. These ghostly sounds were created using data from sound waves collected by the Chandra X-ray Observatory. Thank you for watching and listening. And please, don't forget to subscribe.